Hello chemists, today we're going to be talking about periodic trends. Specifically, we're going to be talking about ionization energy and electronegativity. So last video we talked about periodic trends and how they relate to atomic and ionic radii. Basically, as you go down the periodic table, your atomic radius gets bigger, and as you go to the right across the periodic table, your atomic radius gets smaller, and that's because of increasing distance from the nucleus in added electron shells, and also because of added protons generating more attractive force in the nucleus. When we're talking about ionization energy, what we mean by ionization energy is it's the energy required to remove an electron from an atom in a mole of gaseous atoms. So you've got a mole of atoms, and you want to remove one electron from each, and it's how much energy it takes to do that. The first ionization energy, that's the specific type of ionization we're going to be talking about. First ionization energy refers to the amount of energy it takes to remove the first electron from the atoms in a mole of gaseous atoms. Second ionization energy refers to the amount of energy required to remove the second atom. That's always going to be higher. So we're going to talk about first ionization energy first and exclusively. So in order to remove an electron from an atom, it takes some energy because you've got to remove it from its shell, but kind of pry it away. So it takes some energy. It's an endothermic process. So as we remove these atoms, basically the further away they are from the nucleus, the easier they are to remove. So as we move further away from the nucleus, we get less attractive force from the nucleus, therefore it's easier to remove the outermost electrons. So the heavier atoms down at the bottom of the periodic table are going to be quite easy to ionize, quite easy to remove the first electron from them to ionize them. And as we move to the right, as the electrons get smaller, they're going to be more difficult to ionize. So your first ionization energy decreases as you go down the periodic table, and it increases as you go to the right across the periodic table. Big atoms have low first ionization energy. Atoms with quite full shells have a small ionization energy. Okay, that's pretty much it as far as ionization energy goes. There is some work associated with this that we'll be doing in the SciPad. But this relates to electronegativity. Electronegativity, if you recall from previous years, is a measure of how strongly an atom attracts a bonding pair of electrons, how attractive the atom is to electrons. It determines where the electrons can most often be found in covalent bonds. It has a lot of effects on chemical activity. So electronegativity also follows some trends in the periodic table. Electronegativity is how attractive the nucleus is to electrons. If you recall, the most electronegative atom is fluorine. Everything else is less electronegative than fluorine. As you go down the periodic table, you get less electronegative, and as you go to the left across the periodic table, you get less electronegative. So the trend is somewhat the opposite of first ionization energy and of atomic radius. So as you're going down the periodic table, the atoms are getting heavier. They're getting more electrons, more protons, and the attractiveness of the atom to other electrons is getting smaller. Ditto as you go to the left. Your number of protons and electrons is getting smaller. The atoms are getting bigger, and your attractiveness of the atom to electrons is decreasing. Electronegativity uses the scale developed by Linus Pauling, and it maxes out at 4.0. Fluorine's got a electronegativity of 4.0. Everything else has lower electronegativity. At this point, we're not doing a ton with those numbers. All we're doing is recognizing when one is going to be bigger than another. You can look them up for the most part. That's it.